Okay, so we're on page 24 for today. Your homework last time looked at something called multiplicity for x-intercepts. So I'm gonna screen share my notes so we can take a look at this stuff together. Okay, so from our homework last time, the notes that you filled out, you guys looked at different behavior that x-intercepts have. Okay, so this was our homework last time, your notes that you should have been working on. Okay. So some of the different behaviors that we can see with these x-intercepts are what's called linear behavior, when my x-intercept crosses through with a straight line. Sorry guys, we've got people joining us late. When our x-intercept crosses through that axis sort of like a straight line, that's why we would call it linear, because it looks like a line. And so we've seen that already in some of our parabolas that we've seen. We've got places where my x-intercept just crosses right through the x-axis. And if I just zoom in on that little portion right there, or that little portion right there, it looks just like a line. We've also got what we call the quadratic behavior, and that's when my x-intercept basically bounces off that x-axis. So like this guy right here, if I zoom in right here, we call it quadratic behavior because it looks like a little parabola touching the x-axis, right? A parabola is that U shape. So we've got just a little baby one there right on the x-axis. So when we talk about these different behaviors, that's what we're talking about. What does it look like if I narrow my focus just to that x-intercept? So linear behavior, it looks like a line right at the x-intercept. Quadratic behavior, it looks like a parabola right at the x-intercept. And it could be a parabola above, it could be a parabola below. Either of those is fine. And then the last one is what we call cubic behavior. Okay, and that's where just as I zoom in right on that x-intercept, my graph is coming at the x-axis like a line, but then it flattens out. And instead of like punching right through like a line does, it's really flat and kind of pokes through and like sneaks to the other side and then continues on. And we know that all of these different behaviors are indicated in our function with exponents. So we know that if I have an exponent of 1, I'm going to have linear behavior. If I have an exponent of 2 or 4 or 6 or 8, any even number, I'm going to have that quadratic behavior. And if I have an exponent of 3 or a larger odd number, 3, 5, 7, 9, blah, 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 I'm going to have that cubic behavior. So what we're going to do on page 24 with a few of these problems is take a look at what I expect that graph to have based on its function, or based on what I know about the graph, what that function would be. Okay, so let's take a look at number 3. We'll start with the ones where we have the functions, and then we'll look at where we're going to create them. If I'm looking at number 3, I've got 4x squared times x minus 2 to the 5th power times x plus 3. Okay, let me see if I can zoom in just a tiny bit more on that. Okay, so from here, there's a couple things I could do right off the start. Since I have the function, the sign of my leading coefficient is really easy. I look at the function, my leading coefficient is a 4, that's positive, so I'm going to fill in a positive right here. The other thing I could get from my function right off the bat is the degree. I know adding up all those exponents, since I'm not in standard form, will give me the degree here. So my degree would be 2 plus 5 plus 1 for this guy. So that would be 8 is my degree. Last time we talked about how if I know the degree, then I also know the, if I know the degree and I know the sign of the leading coefficient, I also know the end behavior. So since I know those two things, now I know the end behavior for this. Remember, even degree, both ends go in the same direction. If it's positive, they're both going to go up. So I know on my left end, y is going to approach infinity since the left side's going up. On the right end, y is also going to approach infinity since the right side's also going up. And then the last part that I'm going to look at, the new part for us as of last night's homework, is how I determine my x-intercepts and what they look like, their multiplicity and behavior. So when we talk about location, I'm just talking about I have an x-intercept where? X equals what for my x-intercept? So that's not so new. We saw that last time. Where I have x squared, I would have x equals 0 for an x-intercept. X minus 2 would give me 2 for an x-intercept. And then x plus 3, remember it's the opposite sign, would give me negative 3 for an x-intercept. Their multiplicity refers to their exponent. So for each of these, I'm going to say what their multiplicity is. So when x is 0, my exponent is 2. That means our multiplicity is 2. We care about the multiplicity because it tells us what type of x-intercept we'll have, what that's going to look like. From our notes, I know that an even exponent gives me this behavior, gives me a double 0 or quadratic behavior. Okay? So where it asks for our behavior, we're going to say quadratic, and I'm just going to write quad there. It's kind of a small box. For our next x-intercept at 2, our exponent is 5, so our multiplicity is 5. Again, that multiplicity tells me what the x-intercept is going to look like on the graph. Since 5 is an odd number, it's going to look like this cubic behavior. Okay? So we're going to say its behavior is cubic. And then for our last x-intercept here, I don't see an exponent. That means that it's 1. And a multiplicity of 1, or an exponent of 1, means that we're going to have this linear behavior. So I'm going to write linear in here. Questions for me so far? Okay, I don't see anything in the chat, so I'm going to go back to my screen share. Okay, so let's take a look at number 5 now. Same idea, we're answering the same questions, just with a different function. I'm going to start with the same stuff I started with last time, which is that leading coefficient. To me, that's the easiest question to answer here. What's the sign at the front of this function? I don't have to know anything about polynomials to be able to answer that. I just have to have like eyeballs and be able to recognize the difference between a positive and a negative number. So that's like the easy freebie thing in here, okay? Sign of the leading coefficient, well, this says negative 0.56, so that's a negative. The degree is something that we've worked on for a little while, so that one should also be something that we're comfortable with. I'm going to add up my exponents for anything that has an x term. So that would be 3 plus 4, that gives me 7. The sort of, as I'm working through this problem, I want you to notice I'm working through it in the order that we've talked about things in class. So something, recognizing the sign of a number, something you knew before you came to me, hopefully. Degree, right? Something we talked about pretty early on. I think we were even in person when we talked about degree. The next thing I'm going to work on is end behavior. That was the next thing that we talked about in class. So remember, odd degree, they go opposite. Odds go opposite. Since it's negative, I know I'm going to have this general downward trend from left to right. So the arrow on the left is going to be pointing up. So for my left end behavior, y approaches infinity. The arrow on the right is going to be pointing down. So that would be y approaches negative infinity. And then the last thing I'm going to fill in is that newer material. What are the x-intercepts? And what do they look like on the graph? What's their behavior on the graph? So from here, I'm only going to have 2 x-intercepts because I only have 2 of these factors. So I'm going to have x equals 1. So x equals 1. Its exponent is 3. That means I'll have a multiplicity of 3. Since the multiplicity is odd, just like here, I had a multiplicity that was odd. That means I'm going to have cubic behavior. For my next, what we'll call factor here, my x-intercept would be -2. So x equals -2. Our multiplicity is 4, since that's the exponent. And then since 4 is an even number, we're going to have quadratic behavior. So just like here we had an even number, it was quadratic behavior. Same thing here. Questions for me so far? Not seeing anything pop up in the chat. Okay. So let's take a look at a couple examples where we're going to kind of work the opposite way. Okay, we're going to take a look at number 6 and number 8. For these last two, I don't have the function. We're going to create it based on what we see. Okay. So for number 6, I know all the stuff I need to know about those x-intercepts. If I know stuff about the x-intercepts, then I can write a function. We did that 2 days ago, right? That's what we practiced in class. I had the graph, we picked out the x-intercepts, and we wrote a function. Or I had that list of x-intercepts and we used it to write a function. So we're going to do exactly the same thing here. If I have an x-intercept at -1, that means I have x plus 1 in my function. And then the multiplicity part tells me the exponent on that. So this is going to have an exponent of 5. This x equals 0 tells me I have x minus 0 as a factor, or just plain old x. And you could put the x in front if you wanted to, like they did on number 3. We talked a lot about that last time. And then this 4, the multiplicity, tells me the exponent on that thing. These I know by default, right? An odd multiplicity, that's not 1, is going to give me cubic behavior. Even multiplicity is going to give me quadratic behavior. Okay? Those aren't things I really need to be able to write my function. And then the only thing I'm missing here is what that lead coefficient is going to be. So when we worked the other day, it actually said your lead coefficient is blah, blah, blah. This time it doesn't say that. We just need to figure out, is it a positive or a negative lead coefficient? So we're going to use the degree and the end behavior to kind of work backwards to figure that out. They gave us the end behavior. We know the left end has an arrow pointing down and the right end has an arrow pointing up. Okay. Based on that information, I know that my degree should be odd. So when I go to write my degree, right, when I go to fill this box in, I should have an odd number. So if I add up my exponents, 5 and 4, that gives me 9. That matches my end behavior. So I know I did at least something right. Okay, my degree is 9. Now, I can use the direction of my arrows to decide if I need to put a negative sign in front of this function. Odds go opposite, and I've got a general trend up from left to right. That means I would have a positive leading coefficient. So I'm not going to put anything in front of here. If you wanted to put 207 or 3 or some positive number, that's fine. In general, my directions to you are going to be to keep things as simple as you can. So if you knew this was negative, just slap a negative in front of it. Since we know it's positive, I'm just going to leave it alone and put the little f of x in front, or y equals whatever makes you happy. Questions for me? Let me hop back so I can see that chat screen. Okay. Okay, so let's take a look at number 8 now. We know where the x-intercepts are, so I can write those factors. I have an x-intercept at -3. That means I would have x plus 3 as a factor, but I don't know its exponent. So I'm going to leave that alone for right now. I have x equals 2, that means I've got x minus 2 as a factor. Its exponent is 7 because the multiplicity is 7. And then I've got x equals 4, that means I've got x minus 4 as part of my function. Its multiplicity is 1. So if you want to put the 1 there, you can, but if it's 1, we don't need it. Now, to figure out this exponent, I'm going to take a look at the degree that they gave me. They told me my degree is 12. That means if I add up all the exponents, I should get 12. The only exponents I have right now are 7 and 1. So that gives me 8. So 12 minus 8 tells me I've got 4 left over. So that means that has to be the multiplicity or the exponent that I was missing. It would have to be 4. If all of these have to add up to 12, this one's got to be 4. They didn't give me the sign of my lead coefficient, so we'll tackle that in a minute. While we're here working on x-intercepts, since we know all their multiplicities now, we can fill in their behavior. An even multiplicity is going to have quadratic behavior. Odd multiplicity that's not 1 is going to have cubic behavior. 1 is going to have linear behavior. 1 is always linear, and then evens quadratic, odds other than 1 cubic. So I'm almost done with my function. I just need to know if I need a positive or a negative lead coefficient. So let's take a look at our degree and our end behavior. Our degree is even. Odds go opposite, so evens have to go the same direction. And we talked about that up here with number 3. Evens have to go the same direction. I know that the right end goes down. Since evens have to go the same direction, that means the left end has to go down too. So this guy's going to be y approaches negative infinity. Since both my ends are going down, that means my lead coefficient is going to be negative. So I'm going to start this with a negative. I'll do y equals on this one. And that's everything. That's everything I've asked about that function. I want you guys to take a minute and try number 1 and number 7. Number 1 and number 7, give those a try. Okay, let's take a look at these together. I'm going to approach this one the same way I approached the ones that we worked through together. So I'm going to start with degree. That was the first thing that we talked about, so I'm going to start there. My degree, I would get from adding up the exponents on any x terms. So I've got a 4, and this would be a 1 since I don't see it, so my degree here is 5. My leading coefficient is a positive number. I'm going to fill positive in that box. And then our end behavior. Odds go opposite. Since it's positive, I know my general trend is going to be up from left to right. That means this end will point down and the right end will point up. So the left end, since it's pointing down, that arrow points down, I would have y approaching negative infinity. On the right end, since that arrow is pointing up, I would have y approaching positive infinity. For my x-intercepts, I would have an x-intercept at 0 and at 1. So where x is 0, the exponent or the multiplicity is 4. Since 4 is an even number, that's going to be quadratic behavior. When x is 1, my exponent is 1, so my multiplicity is 1. If the exponent is 1, that's always going to be linear behavior. Questions on number 1? Let's hop down to number 7. Same idea with number 7. We don't have the function this time. We're going to fill that in based on the information that we have. So I have the most information, it looks like, here in my x-intercept box. I have an x-intercept at -2. That means I would have x plus 2 in my function. I don't know what the multiplicity is, so I don't know what the exponent is, but I do know its behavior is linear. Anytime I have linear behavior, that means the exponent has to be 1. So you could write the 1 or not, it's up to you. X equals 0 means I'm going to have an x, or in my function, I'm going to have x minus 0, or just plain old x if you want. Its multiplicity is 6, so that means my exponent is going to be 6. Since 6 is an even number, that means it's going to have quadratic behavior. And then our last x-intercept here is 3. That means I would have x minus 3 in my function. I don't know the exponent, but I know it has linear behavior. Since it has linear behavior, the exponent has to be a 1. I also know that the sign of my lead coefficient is positive. That means that this will work as my function. If I want to throw a negative, or if it were negative, I would just have to put a negative in front. Since it's positive, I can leave it exactly as it is. And again, y equals or f of x are both fine here. Now that I have my function, I can use the function that I've written to get my degree. So my exponents are 1, 6, and 1. Add those all up and I would get 8. Now that I know the sign of my lead coefficient and my degree, I can get my end behavior. Odds go opposite, so evens have to go the same direction. Since it's positive, both ends are going to go up. So this would be y approaches infinity and y approaches infinity. Since I'm going up on both the right side and the left side. Any questions for me for today? I don't see anything in the chat. So the last thing I have for you is on Google Classroom. You should have seen, if you get emails and you happen to have yours open, you should have gotten a notification from Google Classroom that you would now have an assignment posted. It's what I'm going to call a quick check, basically. And you're gonna see when you click on that assignment, a Google Doc. You have one problem where you've been given the function and you are telling me well, I guess you guys can't see. I'm pointing at stuff you can't see. I'm not screen sharing. Okay, let's try this again. You're gonna have one problem where you've been given the function and you have to fill in the stuff about the x-intercepts, the end behavior, degree, sign of lead coefficient, all that good stuff, like we did with number 1, number 3, number 5. You're gonna have one more problem where you're given a graph. So instead of the function, you're gonna be given a graph, which is kind of similar to me giving you the x-intercept information. So from the graph, you'll pick out the x-intercepts. From the graph, you'll be able to see the end behavior. So you'll use that to fill in the questions about the multiplicities for those x-intercepts and the end behavior, if you expect the lead coefficient to be positive or negative, and the degree, okay? Where you are filling in the multiplicities for your x-intercepts, look at that behavior and use the smallest number you can. So if I have a graph that, actually, let me see. If I have a graph that, we'll say, looks like this one, and let's say I have an x-intercept at 5, and it's linear behavior. I know linear is always 1. If this is my x-intercept at 2, it's quadratic behavior. Quadratic could be any even number. Just use the smallest number you can. So just use 2 there. If you see cubic behavior, use just the smallest number you can. Okay, so that would be 3. Unless you have a reason to think you need to use a bigger number, like problems where we were given the degree, like here we were given 12, so that gave us a hint as to what we needed for our missing multiplicity, where we were given 12, and we said the other exponents added up to 8, so I had to subtract to figure out that remaining one. Unless you have a situation like that, always use the smallest number you can. Okay. So I'm going to stop sharing and I'm going to stop recording because that's the end of our lecture portion for today.